All right, mathematicians, I know you're probably just as excited as I am to begin our first page of notes in Module 3. Module 3 is going to be working with fractions. We're going to be doing a lot with fractions in Module 3. For this particular lesson, we're going to start just with some review, hopefully some material that you recognize from 4th grade. But in case it's not familiar, we'll spend a little time going over it. Module 3, Lesson 1. So we're back down to our smaller Roman numerals. Just an I for Lesson 3-1. 3-1. Focus. There we go. 3-1. We're going to talk about equivalent fractions. Equivalent fractions. And, as I mentioned before, we're going to do some fraction concept review. Okay? We'll review some important fraction concepts. Now, we do have a little vocabulary to begin with. Always seems like by the time we get to the last part of a module, we're not doing vocabulary as often anymore. I kind of miss it. Okay. Really, it's just breaking apart that one big word, fractions. Okay? Fractions are equal parts. You want to be very careful with that. Sometimes when I'm drawing them on the board or when we're drawing them together on paper, they may not look equal, but we have to recognize that they are supposed to be. Equal parts of a whole. Now, when I say equal parts of a whole, I do mean a whole number, not a hole in the ground. Fractions are equal parts of a whole. And a fraction is made up of two main parts. Well, three, I guess, if you count the fraction bar. The first part is the denominator. The denominator is down. Down. Denominator is down. The denominator is the bottom. The bottom part of a fraction. Denominator is the bottom part of a fraction. It is also, well, it represents the total number, the total number. I love sneezing when I'm trying to record a video. The total number of pieces. Now that part's very important, so I'm going to try to say it again without sneezing. The denominator is the total number of pieces. If I break something into 6 chunks, then the denominator will be 6. If I break something into 23 chunks, the denominator will be 23. The denominator tells you the total number of pieces. Goes the other way too. If you see a fraction that has a 15 on the bottom, then you know whatever whole number we started with, we broke it into 15 pieces. So if the bottom was the denominator, then the numerator must be the top part of a fraction. So numerator is above the fraction bar, denominator is down, denominator is below. Now, this is the number of pieces we are focused on. Focused. Usually in a problem or in a math expression, a statement, something, we'll say a total whole number has been broken up into 15 pieces. 8 of those pieces are shaded in. So we're focusing on the shaded pieces. That's 8 over the 15. We're going to do plenty of examples, so if that's not clicking or familiar, don't worry. We are going to jump down to our next definition. A and B. We went in for denominator and in for numerator because both of these things are part of a fraction. Now I'm going to go back out to 2, so I'm continuing the list from here. I'm going back out to 2 because my next vocab word is related, but it's not the same. It's not a piece of a fraction. A region is one way that we can see a fraction or represent one. A region is a solid, so a physical object, a solid area, or a single item. And I got a little ahead of myself. I got a little excited there. So let's back up and talk about that. Okay. A region, I said a physical object, like a single item. But when it says a solid area, it means something a little different. Picture if we draw a rectangle. Okay. This would be my solid area. It's not a physical thing. It's something I drew on the paper, but it's one piece, right? It's one shape. Now, if I take that shape and break it into that many pieces, that tells me right away what my denominator should be. 1, 2, 3, 4 pieces. Denominator is 4. Denominator is the total number of pieces. Now, if I take one of those pieces and shade it in, do a little lovely cross-hatching there for you folks. Nice. I've only shaded in one single piece. I'm only focused right now on that one piece. So that will be my numerator, 1. Now a different question, how many pieces are unshaded? You have to be careful. If I had asked how many pieces are unshaded, now I'm focusing on these ones, so it would be 3 out of the 4, 3 over 4. So do not think that focus always automatically means shaded. Read the question carefully. Your numerator, your focus, is just whatever you're talking about or being asked about. All right, now a region is how you will often see it in math books, and these are the examples I tend to use most often. But it's not the only way to do it. We can also discuss fractions of a set. Now a set, my favorite example for this is when I start to talk about my Justice League action figures. This is when you have a group of individual items. Now, I am not going to take one of my toys and pull it apart. So this is not a case where I am taking one figure and breaking it into pieces. That's not happening. This is where you have, here's one individual, here's a second individual, here's a third individual, here's a fourth individual. They're not together. These circles could represent anything. These circles could be my figures, they could be pencils, they could even represent pages of math notes. Okay. If I have 4 in the set, then my denominator looks a lot like the one up above. And if I color in one of these items, that's my focus. How many are colored? 1. The exact same fraction, but represented in different ways as far as the pictures, as far as the models go. Now, these fractions are the same. They're literally 1/4, 1/4. They are identical. But one big concept we have to talk about, and we will spend pretty much the rest of the school year going over this. What if fractions look different, but are equal to each other? We call those equivalent. That should be a V. Equivalent fractions. Boy, I'm sneezing. Throat's bothering me a little bit. Take a sip of water. Sorry, folks. Wish I could pause this during recording. It would be a lot easier. All right, equivalent fractions. I just mentioned a moment ago. These are fractions with different numerators and denominators. I'll show you some examples, but basically the numerators, the denominators, going off the screen. Oh, no, that's it. Okay. The numerators, the denominators, they're going to look different. Fractions with different numerators and denominators. They look different. Fractions with different numerators and denominators, they look different, that are equal. Make that an E. That are equal to each other. Okay. So how can that be? How can we have two fractions that look different but are actually equal to each other? Well, let me explain this in a different way. Okay. Equivalent fractions are different fractions. So we got that part, I think. I've said different about a bajillion times. Different fractions that describe the same part of a whole. So even though the fractions are different, they describe the same part of a whole. Okay. Let's draw a region. Let's draw a region. So we'll draw a rectangle. And we'll cut it in half. And we will shade. Now you notice I'm not coloring it quite as dark this time. Okay. We'll shade it in. We'll do some of that lovely cross-hatching. I know how much you all love it. There we go. Okay. I think most of us can identify that fraction. There are two pieces total in the whole. I shaded in one of them. Okay. This is 1/2. But what happens if I slice it again? Okay. Now I have cut another line across the middle horizontally. We had this one already going vertically. Okay, I'm just going to darken this in a little bit, make sure it's nice and clear. I had that one, but now I have two slices. I cut across, and now 1, 2, 3, 4. There are 4 pieces total. And out of those 4 pieces, 1, 2 of them are shaded. Did I shade anything extra? No. Did I go back in and color? Did I do any more cross-hatching? No. The exact same amount of stuff is colored, but I broke the overall whole into more pieces. I broke it into smaller pieces, so I needed more of them. I needed more of them to equal 1/2. And I can play this game all day, as long as I make sure my cuts are creating equal pieces. Now I've got 8 pieces total. Denominator is the total number of pieces. I got 8 total. 1, 2, 3, 4 are colored in. Okay. I don't think I'm going to scratch out any more than that, but if I wanted to, why not? Let's do a couple more. Let's live dangerously. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces now. And if I check here, I got to make sure those lines are dark. 1, 2, 3, 4, 5, 6, 7, 8. Not once did I shade anything else. I did not do any more cross-hatching. All I've done is split the pieces that I already had into smaller and smaller chunks. This is kind of what we were talking about with decimals also. Okay. Now, We will do more with this, but we're coming up on that, well, it's 15 minutes, not too awful, but I know some of you are probably ready to be done with this, and we're getting close to the edge of our page. So let's do one final thing, and then we'll do some more examples together in class. We'll talk more in class. To find equivalent fractions. And you may already see the pattern that's happening here on this one. You might already be noticing there's a bit of a pattern going on up here. To find equivalent fractions, multiply, that's the easiest way that most people will choose to do it, or if you're super awesome, and all of you are, so I know you can do this, to find equivalent fractions, multiply or divide a fraction's numerator and denominator, numerator and denominator, by the same number. Now in upcoming lessons we'll talk about how to find a number that you can divide both of them by. The ones up top are pretty easy. If you take a look, I'm just multiplying top and bottom by 2. Multiply top and bottom by 2 by 2. That's probably the most basic way to start. But if you can imagine jumping from 8/16, let's say I started with that. And in 4th grade you probably did talk a little bit about reducing, simplifying fractions. If I wanted to go from 8/16 to 1/2, I could divide the top 8 divided by 8, 16 divided by 8, and I'd get down to 1/2. Another example, if I start you off with 2/5, let's take that same number. Again, I could pick literally anything. 2 times 8, 16. 5 times 8, 40. That means that my original fraction, 2/5, is equal to 16 over 40. Now 2/5, 1/2, these are starting off relatively small, so you really can't divide. They don't have anything in common that you can divide by. You just kind of have to do the multiplication. Again, I think most people probably prefer that anyway. But as we get further in, you're going to see some that we're going to need to do some dividing. And I'll talk about why it is that we can multiply and divide by the same number. But for today, I think that's probably enough. Ladies and gentlemen, as always, if you have any questions or concerns, go ahead and write those down. Make sure you ask in class. But for now, we're all done with our first notes for Module 3. I'll see you in class.